By now, you have learned to create road infrastructure and add various urban design components such as traffic lights, fire hydrants, and more. Starting with this movie, you learn how to create low-polygon buildings to populate the city blocks. I emphasize the words low-polygon because this is what you will be learning in this movie. The geometry will be very simple, and final looks will rely on textures to give the illusion of detail. This is often needed when dealing with multiple buildings in a scene. High polygon buildings would certainly look better, as they would have more volume detail and more depth. However, you won't be able to afford to have too many and still keep the scene manageable. Since you will be mostly relying on textures to complete the illusion, the first thing you need is to create a texture library. These are certainly available to purchase commercially, but you can also create your own. There's a startup library provided to you with this tutorial, and you're encouraged to add to it. To create a building texture, you need to go out and take snapshots of as many buildings as you can. This is not as easy as it sounds, because inevitably you will have to edit those pictures in an image processing application. Adobe Photoshop is often the application of choice, although others work just as well. When you go out and take pictures, remember a few rules. Choose an overcast day, or at least try to avoid significant shadows. If you're not careful, shadows baked into an image may look weird in a given 3D lighting scenario. Minimize the perspective effect if you can. Take the picture from a distance and use your optical zoom. This may not always be easy, as there may be obstacles that prevent you from moving further back. A picture taken too close will need adjustments to fix perspective vanishing points and possibly barrel distortion. In some cases, there are other kinds of obstacles that need to be removed from a picture. Upper floors and penthouses are usually easy, but street levels are always harder because of trees, cars, and pedestrians that are often in the way. The cleaner the picture is when you take it, and the less effort you will need editing it. However, as mentioned, it is inevitable that you do need to edit the picture in a paint or image processing application. Here's an example. This picture was taken from a relatively short distance, as there was another building behind me when I took it. It needs some perspective adjustments and possibly some other lens corrections to make it flat. Here's how I go about editing it in Adobe Photoshop. Keep in mind that I'm no expert in using Adobe products, so the following workflow is one that works for me. Other artists may favor other workflows. In fact, Adobe Photoshop has some special filters for lens corrections and wide-angle retuning, but here's my personal manual workflow. First, make sure the rulers are enabled. This is done in the View menu. After that, drag 4 ruler lines to create a frame around the area of interest. These become your reference lines. At this point, you're ready to distort the image to fit the reference lines. In order to do that, you need to ensure that the base layer is editable. If it's showing in italic, it means it's locked, as is also shown by the lock icon. All you need to do is right-click and choose Layer from Background. Give the layer a name or accept the default. From the Edit menu, choose Transform. There are two options you can use for perspective adjustments, Perspective and Distort. I personally favor using Distort, but you may find Perspective a bit more predictable. Simply drag the 4 grips to readjust the perspective. Either press Enter to confirm the changes, or Escape to discard them. Try both tools and see which one you like better. If you need to reposition the ruler lines, use the Move tool. Once you have a flat view of the area of interest, you can select that area and crop the image. Make sure Snap Mode is enabled to snap to the reference lines. Add a couple more horizontal reference lines to separate the ground floor from the typical floors and the penthouse. In this particular case, the image doesn't suffer too much from barrel distortion. If it did, you can use the warp tool to fix that. At this point, you can resize the image down to a smaller resolution. High resolution images may affect the performance of your system. Resize this image down to about 512 pixels in width. Now you can separate the various levels by selecting them and copying them to separate files. You'd also need to ensure they are tiling properly. In the case of the ground floor and the penthouse, they only need to tile horizontally. Use the offset filter to offset the picture horizontally by half, 256 pixels. You can see the problem this creates around the tiling seam. Select another similar area and then use copy-paste, Ctrl-C, Ctrl-V, to duplicate the selection to a separate layer. Use the Move tool to reposition the layer where you need it. Next, use a soft eraser to get rid of the edges that clearly show sharp vertical lines. If you need to, use other editing tools to fine-tune the connection. Here, I'll use Warp to adjust the horizontal line a tad. When you're done, flatten the image or merge the various layers, but be sure to offset the image back to its original position. Another way of fixing problem areas is to use the Clone Stamp tool. With that, you can hold Alt to right-click and reference one area, and then clone that area by painting over another. In the case of a texture that needs to be tiled horizontally and vertically, such as a typical floor for example, then you need a two-direction offset. As you did before, clone other areas to fix styling seams. And offset back the image after you flatten the layers. Finally, you can extract other maps for more control over your renderings. Bump maps, normal maps, specular maps, and reflection maps can go a long way to refining a final render. In this tutorial, and in addition to the color or diffuse maps you have, you'll also be dealing with reflection maps. Reflection maps are typically grayscale images that define which surfaces are reflective and which are not. Black areas are matte, white areas are fully reflective. Grays are reflective to a point, depending how dark or light they are. They make a significant difference at render time and make the scene look more believable. To extract a reflection map in this case, it is fairly easy as the only reflective areas are the glass areas. Start by selecting those areas. Use the Shift key for multiple selections. You don't need great accuracy as low poly buildings are often viewed from a distance. Once the 6 window areas are selected, you can use the Alt key to subtract areas if you so choose. Again, you may not need to be so accurate depending on the needs you have for your project. Create a new layer and fill the selection areas using Edit, Fill with a white color or a light gray color. Click to remove the selection. Create another layer below this one and fill it with a black color. all the masonry on this building isn't meant to be reflective. That's it. This becomes your reflection map that you would save separately. Speaking of naming saved files, it goes without saying that you can use keywords like diff, ref, BMP to differentiate the various maps. Also, chances are you will be working in real-world scale, as is often the case when dealing with architectural projects. This means it would be smart to add that information in the file name where you can easily retrieve it. But how do you get that information? Well, the safest way is to take those dimensions on site, but that's not always easy or practical. Sometimes you can make some educated guesses. For example, a typical floor height is usually about 10 feet or about 3.05 meters. This makes the height of this particular image 6.1 meters. Since you have the image resolution, and using Math 101, you can easily derive the width, which in this case would be 8.65 meters. So you could name this color image something like brick, typical floor, diffuse, width 8.65, height 6.1.jpg. The reflection map would be called the same, except for ref instead of diff. Something like brick, typical floor, reflection, width 8.65, height 6.1.jpg. With the widths established, you can now figure out the heights of the ground floor and the penthouse and name them accordingly. For this tutorial, you have enough textures to build a city, but you are encouraged to build your own library. In the next movie, you start learning the basic workflows to creating low-poly buildings.